Hello and welcome, math friends. We are going to be focusing on absolute value inequalities today. We want to recall inequalities in general. An inequality is not an equal sign, but it's when we're dealing with either less than, greater than, less than or equal to, or greater than or equal to. And so you have a range of values for your solution. An absolute value is the distance of a number from zero. So we're going to be combining those two things together. Now, when we're talking about distance, the distance of a number is always positive. Distance is never negative. You can't run a negative mile. If you change direction, that's just direction. You're either coming at from the negative side or the positive side, but it's still going to be a positive distance. When we're solving inequalities or equations, we reverse that order of operations. So our goal when we're solving absolute value inequalities is to undo to get the absolute value by itself before we then approach the absolute value inequality by looking at both solutions. Remember that the absolute value distance could be coming from the negative side or the positive side. So we're going to have two different solutions. So what we do when we're approaching these inequalities to solve is we isolate that absolute value, and then we're going to solve for the positive and the negative. When you have a less than sign, it's actually quite easy. You drop the absolute value inequality and you write the less than twice with a negative. I'll show you what I mean by that. When you have a greater than, you have a little bit more strategy to use. So let's talk about compound inequalities really quickly and then come back. When we went over the linear inequalities video, compound inequalities are inequalities that are either combined with an and or an or. So you're talking about in between or out. So what I mean by that is x can be greater than 1 and less than 5. So that's and. Or x can be less than 1 or greater than 5. So I'm going to graph both those and show you what I mean by that. Even though you don't see the word and on the left one, that is an and. X is greater than 1 and x is less than 5. On the right-hand side, that compound inequality is x is less than 1 or x is greater than 5. And when I graph these, you'll notice that they look different. Both graphs have an open circle at 1 and 5 or a parenthesis, depending on which way your instructor is asking you to graph. However, to be greater than 1 and less than 5, their shading goes in between the two. Greater than 1 is to the right, less than 5 is to the left. So the region that makes this true is in between the two. Less than 1 is to the left, and greater than 5 is to the right. So if you notice, in the compound inequality with and, the graph goes together, and the compound inequality for or splits. And if I was to write that in interval notation, this one would be 1, comma 5. And this one would be from negative infinity to 1 in union with 5 to positive infinity. We want to keep that in mind when we're solving our absolute value inequalities. The strategy is, and there's multiple ways that you can approach this. I'm going to show you the way that I prefer, but you might see another strategy in a different YouTube video. Let's say I have x, the absolute value of x is less than 5, and I have the absolute value of x is greater than 5. When you think about absolute value, the distance from the negative side and the distance from the positive side are both the same. So this is actually saying here that positive x is less than 5 and negative x is less than 5. But remember, when I have a negative, if I want to isolate that variable, instead of just having x, I would divide both sides by that negative, and I would get x is actually greater than negative 5. So if x is greater than negative 5, but less than positive 5, that's the region between, and I can rewrite this as negative 5 is less than x is less than 5. So when you have a less than and your inequality to begin with, that turns into an and compound inequality. And the way in which I actually like to write that is I would write instead of absolute value is less than 5 and write it in two separate equations, I would actually rewrite that as the negative on the left less than x less than 5. And then I would solve from there. That's what my strategy is that I'm going to be using. Now, if I look at the one where I start with the greater than symbol, that's saying that x is greater than 5 or negative x is greater than 5, which actually becomes x is less than negative 5. Now, from negative 5 being less than negative 5 is to the left, and being greater than 5 is to the right. This is an or compound inequality. I cannot combine those two together. I would need to say that x is greater than 5 or x is less than negative 5. So it's important that you pay attention to the symbol when you start out. If you have absolute value on the left with the less than and then some number, you're good to go to split it into an and compound inequality. If it's absolute value on the left with a greater than symbol, it's going to be an or compound inequality. So let's get into solving some examples. Okay, we're going to solve and graph each of these inequalities. I'm going to use interval notation for my solutions in addition to set notation, as well as showing both graphs in case you see one version for different with your instructor, depending on what they prefer. That way you can see both options. I start out with the absolute value on the left-hand side. And I want to make sure that the absolute value is isolated, which it is. I don't have anything on the outside. I'm good to go so that I can go ahead and drop the inequality symbol and proceed solving the positive and the negative. It's less than or equal to, so I can go ahead and write it as a compound and inequality. That's going to become negative 18 is less than or equal to 6x is less than or equal to 18. And the way in which I approach this is I'm going to divide the 6. The goal is to isolate that x, single variable, and I'm going to do it to each term. I'm going to do it to the term on the left-hand side of the inequality, in the middle, and on the right. So instead of thinking of it as both sides of the equation, you have 3 parts that you need to be working with. Negative 18 divided by 6 is negative 3, is less than or equal to 6 divided by 6 is 1x. 18 divided by 6 is 3. Writing that in set notation is to say the set of all x such that negative 3 is less than or equal to x is less than or equal to 3. And in interval notation, that's going to be negative 3 to 3. And when I graph that, your teacher might ask you to use brackets. They might ask you to use circles. It just depends on what you're used to. And remember, a compound and goes together. You could graph it like this, or you could have closed circles like this. Just depends on the method that you use. Okay, moving on to the next problem. I have the less than symbol here, the inequalities on the left. I'm good to go. I can go ahead and solve this as an and compound inequality with a negative 8 is less than x plus 4 is less than 8. Subtracting 4 from each of those terms, I have negative 12 is less than x is less than 4. Set notation, interval notation. Always write from least to greatest. And then if I was to graph this, if I was to graph using parentheses, that would look like this. And with dots, it would be open circles. Okay, and that would be on the graph. Just depends on, again, the method that your instructor is asking. Moving on to our next problem. Here I see that I have an absolute value. It's not isolated on one side of the inequality, so I'm going to need to handle that 7 first. Undo the addition by subtraction. I have the absolute value of x is greater than or equal to 5. And I have the absolute value on the left-hand side, which is great, but I have a greater than symbol. So remember, I can't just rewrite it the way that I did before as an and. This is an or. That means I'm going to have x is greater than or equal to 5, or x is less than or equal to negative 5. Now, some texts will use the positive and the negative on the left-hand side. I prefer to do it on the right-hand side. Graphing this, remember that an or is going to go towards infinity. Set notation would be the set of all x's such that x is less than or equal to -5 or x is greater than or equal to 5. Interval notation would be from negative infinity up to -5 with a bracket and union with 5 to positive infinity. And infinity gets parentheses, remember, because infinity is not an actual value. You can't take infinity as a value. Graphing using the parentheses and brackets, I'm going from -5 down to negative infinity, and I'm going from 5 up to positive infinity, or you know that it would be closed circles. Moving on to our next problem. We have 6 plus 9x is less than or equal to 24. I have the absolute value on the left-hand side by itself. I have a less than symbol. I'm good to write this as an and inequality. So I can say -24 is less than or equal to 6 plus 9x is less than or equal to 24. I'm reversing the order of operations here, which means I'm going to undo the addition before I undo the multiplication. So I'm going to subtract 6 from all three components. That gives me -30 is less than or equal to 9x is less than or equal to 18. Divide each piece by 9. And I get -30 is less than or equal to x is less than or equal to 2. And -30 can be reduced by 3. That's -10/3. Set notation would just be x such that. Interval notation would be -10/3 to 2. And then graphing, I'm going to be very basic here. Graphing would be together with brackets or circles closed. All right, one last one that kind of involves a little bit more complex operations. I have the absolute value on the left-hand side, but I have a greater than symbol, and I have a -1 on the outside and a 2 that I need to handle. So remember, I'm going to undo the subtraction first by adding 1. I then have 2 times the absolute value of 10x plus 7 is greater than 74. And then I undo the multiplication by 2 and divide by 2 on both sides of the inequality. I then have the absolute value of 10x plus 7 is greater than 37. Now I can split the inequality, but remember this is a greater than symbol with the absolute value on the left, which means I need to make this an or. That's going to be 10x plus 7 is greater than 37, or 10x plus 7 is less than the opposite. Solve both of these. I subtract 7. I get 10x is greater than 30. Divide by 10, and x is greater than 3. Or I have 10x is less than -44. Divide by 10, and I have x is less than -44/10. I can divide both of those by 2. That's going to be x is less than -22/5. In set notation, I'm going to say the set of all x's such that x is less than -22/5 or x is greater than 3. And for interval notation, because it's an or, I'm going to write from -infinity to -22/5 and union with 3 to positive infinity. And these are all parentheses because infinity always gets parentheses. And this was a greater than and less than symbol. On my graph, I'm going to make it very bare bones like I did the last one. I have -22/5, 0, and then 3. That would be to the left with a parenthesis and to the right with a parenthesis from 3, or open circles heading in the outside direction because it's an or. I hope this video was helpful. Thanks for watching.